This is Chapter 2, Question 45, involving the direction cosines of a force and the use of those direction cosines. In the problem, we are given that the magnitude of the force is 400 newtons, that beta, the angle between the y-axis and the force vector, is 60 degrees, and that gamma, the angle between the z-axis and the force vector, is 45 degrees. We are asked to find the x, y, and z components of the force vector. And over here we have the equations of the direction cosines written out to use those to find the x, y, and z components of f. So first we need to find the third angle of the system. And here we can manipulate the first equation, cosine squared alpha plus cosine squared beta plus cosine squared gamma equals 1, to isolate alpha and solve for alpha. So first we get that cosine alpha equals the square root of 1 minus cosine squared beta minus cosine squared gamma. Plugging in values, we get that alpha equals 60 degrees or 120 degrees. And looking at the figure on the left, we see that alpha must be greater than 90 degrees. This figure is a depiction of the figure in the book, which is a drawn out real-life example that the question is based off of. So if you want to look that up, that is 2.45 in the book. So the next step would be to solve for the force vector and the I, j, and k components, which represent the x, y, and z components of the vector. So in order to do that, we have to multiply the magnitude of the force vector times the unit vector. When we do that, we get 400 cosine alpha in the I direction, plus 400 cosine beta in the j direction, plus 400 cosine gamma in the k direction. So when we plug in the alpha, beta, and gamma values, we get that f of x equals negative 200 newtons, that fy equals positive 200 newtons, and that fz equals positive 283 newtons. So that is the last step in this problem, to find the x, y, and z components of f. But as you can see from the equations above, we can manipulate the last three equations to simply find the x, y, and z components of the force vector. On this slide, we see those equations further manipulated to isolate the x, y, and z components, labeling them 1, 2, and 3, respectively, to the x, y, and z components. And plugging in values, you can see that we get the same values of the fx, fy, and fz from the previous slide. So either way works, it just depends on whether you prefer the equations route or the solving it through vectors in I, j, and k system.